Yeah, hello. I'm happy to be here in Budapest and to be a speaker at Hacktivity 2015. And I don't know what you know about this topic. Maybe some of you have never heard about before Dual Stack Lite, and I hope you will learn about this kind of access technology. At first, some information about myself. My name is Micha Borrmann. I'm from Germany. I'm employed as a penetration tester. Mostly I analyze web applications and company networks. And even this talk is based on a real penetration test. That's the reason no company names and also no specific issue will be addressed here. But I found some problems in the based technology, and that's the reason for the talk. We talk about internet access at home. The traditional internet access is you have a router at home and devices are connected to this router. It doesn't care, it's with Ethernet cable, wireless or whatever. But this router, it's so-called a customer premise equipment, CPE, has one public available IPv4 address, and there's a small home network where you have private IPv4 addresses, usually 192.168.0.0/24, for instance. And this router makes network address translation for you. Every device can connect to the internet, but it's not possible to connect from the internet to any of your internal devices directly, but you have on most CPEs the possibility to configure a so-called port forwarding. It means one port, for instance 8080, you forward to your internal device, and that's the reason you can reach your network attached storage, which is located in your home network outside from the internet. Mostly you use DNS for such things, and I believe a lot of people have such kind of traditional internet access at home. Please raise up your hand. Who has a traditional internet access at home? Yeah, I see a lot of hands. That's my expectation. In the future, maybe we will have only IPv6. And one of the big differences is that every device has a worldwide reachable IPv6 address from everywhere in the internet. And from my point of view, such kind of internet access is not available today. Or is anybody here with such kind of internet access? I see one hand. You don't have IPv4? Oh, I haven't listened to the answer. But in the future, only IPv6 is available and no IPv4. Maybe some of you have such internet access, but that's not a product for the main customers today, because a lot of services are not available with IPv6, and you need IPv4. However, IPv6 is growing and distributing more and more. A couple of years ago, there was a nice RFC published, RFC 6540, and it means IPv6 support is required for all IP-capable nodes. That's the reason I called recent internet access with a dual stack. Then you have IPv4 and IPv6. Is anybody here who has such kind of internet access at home? IPv4 and IPv6? Okay. Same guy then. He raised up your hand before. Such kind of internet access is providing more and more. I'm from Germany, and I expect that we have nowadays millions of clients with such kind of internet access. They have IPv4 and IPv6. For IPv6, that's the same than I described before. In general, every device is possible to connect directly from the internet. And for IPv4, the CPE works as a network address translation router, like on a traditional internet access. However, the IPv4 address space is exhausted, and the problem is IPv4 addresses are not available anymore, public reachable IPv4 addresses. In Austria and Germany, in summary, I know 5 access providers. They are not able to provide you with an IPv4 address because they don't have it. And what can they do? They are successful. They have a lot of customers. We talk about 100,000 or 100,000 of clients of CPEs, but no IPv4 addresses are available anymore. There exist some solutions, some are proprietary, but there's also a standard for it, and this standard is called Dual Stack Lite. In contrast, that's a full dual stack. It means IPv4 and IPv6 is available on that line. That's dual stack, and Dual Stack Lite is similar, but yeah, different. And I will describe you how is this access technology working and what security features or interesting things are related to it. That's the overview. This CPE is provided with an IPv6 address from the access provider. And for IPv6, there's no difference to a recent internet access. It means IPv6 is going directly from the CPE to the internet, and in general, all internal devices which have an IPv6 address are also in general reachable from the internet. Maybe there's a firewall on the CPE or something like that. But what happens with IPv4? The most important difference, the CPE does not have a public available IPv4 address. There is no IPv4 anymore. The device has externally only one IPv6 address. And in this configuration, it's called Dual Stack Lite. It's specified in RFC 6333. There's an important device on the side of the access provider. It's called the Address Family Transition Router, the AFTR. That one. And Dual Stack Lite enables access providers to share IPv4 addresses among customers by combining 2 well-known technologies. It means IPv4 and IPv tunneling here, and so-called carrier-grade net. It's done at the AFTR. And there's a distinction, if you have an access with Dual Stack Lite, between an IPv4 capable and a so-called IPv4 provisioned device. On a traditional or a recent internet access, the CPE was IPv4 capable. With Dual Stack Lite, this router is only IPv4 provisioned. It doesn't have a public IPv4 address on the external, on the broadband side. Internally, they provide IPv4 addresses for the devices in your home network. Yeah, I will not talk about specific bugs in a CPE which provides you with an IPv4 address, and I will also not talk about bugs in a specific AFTR. There are some vendors, they provide devices for access providers. It means there are different AFTR vendors nowadays and different router vendors. I've analyzed at least 3 or 4 different CPE models from 3 different vendors. So there are some on the market. The technology itself. From a user perspective, the AFTR works for you like a proxy. A proxy for TCP, for UDP, and for ICMP. I think some of you will provide services for clients. It means a mail service, VPN service, or whatever. And there's one important hint for you. the AFTR, all on the market, do not support IPsec directly. And I know big companies in Germany, that's where I come from, that companies, they have users, they use the VPN connection with their IPsec gateway. They cannot use it anymore because they have at home such a Dual Stack Lite internet access, but they don't understand what happens here. They only call it's not possible to use the VPN to our company. I cannot work anymore. And now that's the point that these VPN gateways are switched to dual stack. It means the VPN gateway has to support IPv4 and IPv6 as well. Then it's working because IPv6 can be used directly. And most clients nowadays have IPv6 enabled. It means Mac OS, Windows, and Linux. As the CPE does not have a public reachable IPv4 address anymore, it's also not possible to configure a port forwarding. If you have a network-attached storage in your home network, which is not supporting IPv6, and you have such kind of internet access, you cannot use this network-attached storage from the internet anymore. There's no way. You have to enable IPv6. That's maybe important to know if you have a NAS at home and like to reach it from the internet. But I've heard Dual Stack Lite is not here in Hungary present in the market, but in Germany and Austria and Germany, I think also more than 100 million users have such internet access with Dual Stack Lite. And the IPv4 addresses are limited because they are shared among the customers. Ports became a critical resource as well. If you have an IPv4 address with maybe 1,000, 2,000, 5,000 people to the same time, you cannot have 65,636 ports for you, only less. And how does it work? How these ports are designed? To analyze it, I wrote a very simple PHP script, but it's possible with every programming language you like, and put it on a web server. And I request this script. It only prints my source IP address and my used source port with a common IPv4 access and also with a common IPv6 access from a home device. If there's only one device active, the used source ports are simple incremental. You see it here. If you run the same script with IPv4 from a client which is accessed via Dual Stack Lite, the result is different. Well, it's a little bit shorter here, but you see 36,088, 36039, and then, the connection is not possible, and the connection is still active, but with other ports. I did it for 100,000 tries, sequentially, and then I displayed it. Yeah, that's traditional, simple, incremental. It depends on your operating system, how it works in detail. There's no source port randomization here, but on a usual operating system, it's simple incremental. If it's reached 65,636, it goes back to half and start again to increase with IPv6 and IPv4. With IPv4 with Dual Stack Lite, it looks totally different. That's one example. And you see here are some gaps. It was seen the connection was lost before. And I zoom in a little bit to look at more deeper, and I detect I have 4 small ranges of ports which are assigned for me, for my CPE, which I can use, but they are blocked for a limited time, and if my allowed number of ports are over, I cannot use any port anymore. For demonstration purposes, I created a website with a lot of pictures from different websites. And if all these external resources come from different IPv4 sites, and I have access with Dual Stack Lite, the browser tries to connect to all these sites via the AFTR. And for every request, a new source port is required. But if the limit is reached, which is configured on the AFTR side, the pictures will not display it anymore. However, how is the assignment of source ports? That was a result I've detected on one AFTR, but I can say the assignment of source ports, it depends on the vendor of the AFTR. There are different vendors, and the kind of source port assignment is different. It's not the case that you have 4 blocks in different spaces. It also depends on the configuration of the AFTR. It's possible to configure, maybe the access provider assigns a maximum of 500 source ports for each CPE. And it depends on the firmware of the AFTR and also on the load on the AFTR. These are big devices in access provider networks. They run a bandwidth with 40 gigabit per second or so, and believe there's a lot of traffic there. I've seen one case, there was a source port assigned to a client, it means to a CPE, and less than 1 minute later, the same source port was assigned to another CPE, to another client. It's dynamic. It depends, on the load of the AFTR, configuration, firmware, and the vendor. And more than 5,000 people can share one single IPv4 address. That's the fact. It works. And now there are some necessary tasks if you provide services, like a mail service or whatever. At first, enable IPv6, especially for IPsec, but in general, if you provide services, please provide it also with IPv6, because millions of people don't have IPv4 anymore. And also the access provider don't like to pay for these AFTR because it costs money and they don't have to do it if IPv6 is available. If people go to Facebook, to Google, to YouTube, whatever, all these sites are available native with IPv6, but other sites not yet. The other point is, if you have IPv4 services, increase the number of current connections. One public email provider in Germany, his POP3 server was available only with IPv4. And I know clients, they have a Dual Stack Lite internet access. They switch their device on, they try to reach mail, and they get an error message, too much current connections from your IP address. 5,000 connections from one IP address. It looks a little bit strange, but it's not malicious traffic, it's usual traffic. If the source IP address is shared by maybe 5,000 users. And if you have IPv4 as well, you should enable source port logging. There's also a RFC, which is required for sharing IP address. Here's an example, if you have running in Apache, how to activate the source port logging. It's very simple. If you have strange traffic and you like to identify what was the client, usually you need the help of the police. I think that's the same case here in Hungary. But if the IPv4 address is shared for thousands of customers, the IPv4 address itself is not enough to identify the current customer. You need the source port also, because the AFTR has an extended network address translation table. There's also the assignment between the current source port and the CPE. Well, that's all about ports. Now, we should have a deeper look in the tunneling IPv4 over IPv6. This tunneling is quite old. It's from the 19th, RFC 2473. And yeah, it's more or less 2 times layer 3. You know, layer 3, layer 4, layer 2, whatever. But 2 times layer 3 sounds strange, isn't it? I have a simple demonstration. There's a packet. You can build it with Scapy, for instance, and even this next header equal to 4 is not so good documented. But if you create such a packet, I've prepared it here. It means a source address, a destination address in IPv6, and a source and destination address in IPv4. And if you show the packet, you see IP, that's what you expected, and IPv6. Both is layer 3, but you have 2 times layer 3. That's a little bit strange. If you run TCP dump, it's the same. You see IPv6 and IPv4 for 1 packet. ICMP Azure request in that case. How about Wireshark? Here, so example, packet dump, you only see IPv4 addresses. If you filter for IPv6, you should expect to see nothing. Wow, there's 1 packet. Here, Wireshark is displayed in the overview. Here, only the highest layer 3 packet, not all. And here, I have layer 3 IPv6, and above or below, depends on your point of view, there's IPv4, and then the payload, or the layer 3 protocol, the layer 4 protocol. It's a little bit strange. If you see it first time, then I have 2 times layer 3, and you can combine it. You can have a layer 3 3 times, 4 times, whatever. It's possible in general, but it's a little bit strange. But this packet is really nice. If you have seen this tunnel, and this tunnel runs between your CPE and the AFTR. Here is IPv4 tunneled over IPv6 because the access provider has IPv6 only network, or can have. And on that way, this tunnel is active. If you're a client and you use Dual Stack Lite, then you can imagine your access provider can see your used private IP addresses, because the router does not work as network address translation router anymore. It's done by the AFTR, because so-called carrier-grade network address translation, CGN, is used. There's also an RFC for it. And the access provider can monitor how many devices my clients have. In the past, in Germany, there were contracts available. You were allowed to have only 1, 2, 3 devices on your internet access. It's not the case anymore, but maybe there's a contract which is limiting the number of concurrent devices. And now it's more easy for an access provider to monitor how many different devices do you have at home and which private IP addresses do you have. Because all this information is possible to see in the tunnel, which ends at the AFTR. Well, this tunnel, IPv4 over IPv6, what do you think? What kind of authentication is there available? No answer? That's right. There's no authentication. And this was interesting for me, and I've developed the following attack. It means I try to attack all IPv4 devices at home if you have Dual Stack Lite internet access. As an attacker in the internet, I should try to spoof the AFTR IPv6 address with a unique, reachable public IPv4 address and send this packet to the CPE, to the router. The router decapsulates it, and it results in IPv4, a normal IPv4 packet. It comes from the internet and sends it to a device in the home network, maybe a printer. The response goes to the CPE. It sends it to the AFTR, tunneled in IPv6. And then, with IPv4, it's sent to the internet, and it was reached from the attacker. But the interesting point is, you can have a direct connection from the internet to a private IPv4 address. Is this running only on this presentation slides here, or is it running really? Well, here's a small how-to for Linux. It's quite easy to perform it. It's really a workshop how-to here. You have to enable a kernel module for IPv4 and IPv6 tunneling. Then you have to configure the IPv6 address of the AFTR as an additional IPv6 address on your system. Here. This address of the AFTR. The CPE knows this address. This is provided, for instance, with TR069 protocol or something like this. But that's not a secret. Then you have to define a tunnel, the label no more private IPs, it's only a label, you can use any name. And you have to establish this tunnel from your spoofed IPv6 address to the IPv6 address of the CPE, of the router at home. Because this tunnel is without authentication and it's stateless. Then you have to enable the tunnel. After that, you have to enable a routing to a private or to any used IPv4 network behind this CPE. Mostly it's 192.168.0.0 or something different. Mostly it's vendor dependent. And then you have to send a packet through this tunnel to a private network. NTP is only one packet. It reads some information from an NTP service, and I run this program from a system on the internet against a private IP address. But, oh, request timed out. It doesn't work. Sure? Why is it not working? You send a packet. That way, maybe here's an NTP service running. The response goes that way, that way, that way, that way. Here, it should be received here. The reason is your IP stack sent it to 192.168.0.1, but the response comes, in that example, from 80.1 to 2.3. And usually your IP stack will not recognize that's the answer of my request. And also ports are different. The easiest way to record the answer is TCP dump. And that's a real output. Not live, but captured on a real system. And you see here, this answer comes from the AFTR IPv4 address to my IPv4 address, and all the content can display it. And that's a difference. It's a possibility to connect to an IPv4 device with a private IPv4 address in a home network without having port forwarding or anything else. It works with UDP and ICMP. It means you can ping all your sites at home. And if you have time, maybe you can write a modified IPv4, IPv6 stack, which can detect packets which are assigned to the same data stream, which they come from different source IP address than you send a packet to. It should be possible if you have time and a bored hacker, maybe. Then it's a new project for you. It works not with TCP directly. At least there's a three-way handshake. And some AFTRs have an integrated stateful inspection firewall. It means if you send here a SYN packet to start the three-way handshake, this device sent a SYN acknowledge packet to the AFTR, but the stateful inspection firewall here drops this packet. It will not come that way. But with UDP and ICMP, it works fine. And with TCP, you can have so-called acknowledge scanning. It means only an ACK packet. It's sent through all AFTRs I've checked in the past. What do you need? You need, as an attacker, a system with dual stack on the internet. Okay, that's easy, that's usual. You need the IPv6 address of the CPE from a DS Lite customer. That's different. Difficult, because how is this IPv6 address in use? Mostly the users don't know their IPv6 address of the CPE, because if they have an outgoing IPv6 connection and they go to a website like, who am I, please show me my IP address, they display the IPv6 address of the device itself. If they go to an IPv4 site, the IPv4 address of the AFTR is displayed. The CPE IPv6 address is more or less a secret, but it's not so called a secret. You need the IPv6 address of the AFTR. That's also simple because mostly all clients of one access provider have the same AFTR. You need the IPv4 address of the home network. That's easy to guess, mostly. And you need the possibility to spoof IPv6 address from the AFTR against the CPE. However, how is it possible to spoof it? Here, this attack is displayed as running from one system. But that's not necessary. With stateless one packets like UDP or ICMP, you can send the spoofed IPv6 address even if you are also a Dual Stack Lite client from the same access provider. You send it to another client of the same access provider. And the result cannot go to you because you don't have a public IPv4 address, but you can send it to an IPv4 address which is under your control on the internet. There's no possibility to detect this kind of attack is joined to the same thing, because one client is sending a strange packet to another client in the same access provider, and the result goes to anybody in the internet. It's possible. Well, I work as a penetration tester, not as an attacker, and my goal is to improve the security level. And there are some measurements. If you are a customer who has a Dual Stack Lite internet access, do not publish your IPv6 address of your CPE, because it's a secret, the only one secret you have. But it's not so-called authentication, but it's the only one secret. And the other point is, please protect all your devices in your home network. Because even if you have, for instance, a printer, which is able to reconfigure with SNMP community string private, a lot of network printers can modify it in such a way. And even if this printer is not configured to use the internet, because there's a static IP address in your home network, and it's only reachable from your devices at home, the printer itself cannot send it here because no default gateway. He can send only to that devices. But such a packet can enter the device from the internet, and SNMP modification is only in one UDP packet. Even if there's no default gateway on your printer, it's possible to modify it with SNMP, because SNMP is the acronym for security, not my problem. If you're an access provider, I can strongly recommend to all access providers enable anti-spoofing measurements as much as you can. On the border router for BGP, also on every network device between your CPEs and the AFTR, and on devices between other parts of your provider network. Even some access provider also offer dedicated virtual server, dedicated or virtual servers, and there's no anti-spoofing protection between these servers and clients for access providing. So from such a server, it's easy to run a spoofing attack against these clients. And a last hint, if you're a CPE vendor, please protect your log files. Because if the CPE, the routers, looking for a firmware update and download it, in all these files, the source IPv6 addresses of the CPEs are included. So these log files are important for attackers, or they are confidential. Well, my last point is, even for service providers, please enable IPv6. You may ask, why? I don't run IPsec service, and my service is only a simple TCP service like mail or web. And also, all clients with Dual Stack Lite can use my service. In general, that's true. But what happens if the payload of your datagrams are very close to the maximum transfer unit? Because the encapsulation takes 40 additional bytes for the IPv6 header. And if you're serving huge files, uploading videos, for instance, then the packet size is important. A small ICMP Azure request doesn't care. And these packets, if they are too big for the encapsulated tunnel, will be fragmented. Here. It means here comes the IPv4 packet with 1,500 bytes total size. Here, it will become a size of 1,540 bytes, the additional IPv6 header. And then the packets are fragmented on that way, and not fragmented on that way. But in general, if packets are fragmented, it means the number of packets is increased and the performance will decrease. And I hope you don't like a slow performing service. That's the reason I strongly recommend, please enable IPv6 on your services. Yeah, that's it. I can say thank you for your attention. If you have questions, you can ask me here or by mail. If you like encrypted P2P, I like security. Yeah, thank you for your attention. Or is there questions here directly? No, not. Thank you.